Hi everyone. Before, when we were dividing by a pure imaginary number, the fix was very simple. But now, in our next example, the denominator is not pure imaginary. First of all, we need to rewrite this expression so that we simplify the radicals. What is the principal square root of negative 16? It is 4i. And what is the principal square root of negative 9? It is 3i. And we must simplify radicals immediately. So we have 4i over 4 plus 3i. Again, the denominator is not pure imaginary. So if we're going to realize or rationalize the denominator, we should multiply the top and the bottom by what? The what of the denominator. Again, the parentheses here can be helpful. Let's multiply by the complex conjugate of the denominator, which is 4 minus 3i. Multiplying the bottom and the top. We're multiplying by 1 overall. Again, we're multiplying by 1 creatively so that we can get what we want. In this case, a real denominator. All right, now, when we look at these denominators, when we multiply them together, there are different ways you can do this. The shortest way you can do this is to use the rule that we set up earlier in the notes. Remember, if z is the complex number a plus bi, and if z bar is the complex number a minus bi, so it's the complex conjugate of z, remember that their product is a squared plus b squared. If you're brave, go ahead and use that rule. It's very fast. Basically, it's going to be 4 squared plus 3 squared. And it doesn't matter if the minus sign is here and the plus sign is there. As long as you have split signs here, you're going to have the square of 4 plus the square of 3, which is 25. Now, if you're not comfortable using that rule, that's okay. You could use a more old school rule, such as this. Anytime you take the sum times the difference of the two same guys, you're going to have a squared minus b squared. The first guy squared minus the second guy squared. All right, so you get the square of 4 minus the square of 3i. That's fine. And that works out to be, in the end, 25. Of course, just like before, you should get the same simplified form for the denominator using all these methods. Or if you want to go even older school, you could use FOIL, the distributive property. 16 minus 12i plus 12i minus 9i squared. You see that the I terms cancel out, and you end up with what we get over here, basically. 16 minus 9i squared, which ends up being 16 plus 9, or 25. So regardless of the method, you should end up with 25. This rule gives you the fastest way of doing it, but the older school methods also work. Okay. So the denominator is 25. On the top, we end up with the product of these. We get that from the distributive property. 4i times 4 is 16i. 4i times negative 3i is negative 12i squared. And what is negative 12i squared? It's negative 12 times negative 1. That's going to end up being a positive 12. You don't have to show this step, but you should show this, that you get 16i plus 12 in the top, and we still have 25 on the bottom. Remember, the goal is to get standard form, a plus bi, where a and b are real. We have two terms here. Let's split the fraction. So we get 16i over 25 plus 12 over 25. Remember, the I on top can pop out. So we get 16 over 25 times I plus 12 over 25. We're not quite done yet. The real part comes first. Switch the terms, and we get that. This complex number divided by this complex number ends up being this complex number in standard form. 12 over 25 plus 16 over 25 times I. Next, we're going to talk about complex zeros of functions, including imaginary zeros, which is why we're bringing this stuff up now.